Hi, it's Mr. Benson here. I'm currently on my deathbed at home with a very serious cold, but it shows my dedication to physics that I'm creating this video for you. In the holiday homework, marks are on compass, by the way, if you've handed that in, and if you haven't handed it in, please hand it in soon. So anyway, in the holiday homework, there was the question about me braking the car to avoid running over some students. And that one was answered pretty well on the whole, but a lot of the people who answered it correctly didn't do it in the nicest way. Now, there's a way that I'd like you to approach the motion problems, particularly these ones, because there's a whole lot of equations that we can use, and it's important that you choose the right one so that you can answer things in the quickest way. So, the main thing here is you want to try to solve in a single calculation. So the process is you write down what you know. So this is what information in the question is known and is relevant to what I'm trying to do. Write down any values that are implied. Now, what I mean by this is that there are certain things that may not be specifically in the question, but you should be able to work out what they are. So for example, if something is stopping, then its final velocity will be 0. If something is being dropped, then its initial velocity will be 0. If anything is falling, then the value of the acceleration is a constant. That sort of stuff. Write down what you want to know. So what is the question asking you? Because that is obviously pretty important as well. Choose the right equation. So this is where you look at the information that you have, and there should be only one equation that actually allows you to put all those bits of information into it. I reckon you should write down the equation first before you substitute. Then substitute and solve. Now, it doesn't matter if you're a rearrange the equation and then solve them person, or a substitute and then rearrange them person. Either of those things is going to work. There's a chicken in my house. I'll just get rid of that. Right, where was I? Okay, so substitute and then so you can either rearrange the equation and then substitute, or what's often easier is to substitute, and what you'll find is a lot of your terms will evaluate into simple numbers. Some of your terms will disappear completely and it becomes easier to solve. Then, last thing, make sure that you write the answer with the correct units and significant figures. It is it's a really important skill. It demonstrates your understanding better, and certainly the significant figures part is something that they are looking for in Year 12, units not so much. So, let's have a go at doing one. So, here is an example I've made up. I'm pushing a shopping trolley through Bayside Shopping Centre. Now, let's think about, while I'm reading through this, let's actually think about the information that I'm being given here. So, now how you like to do this is completely up to you. I'm going to get a highlightery thing out here and I'm going to start highlighting some information. So, I'm walking through the shopping centre at 7 meters per second. So, here's a piece of information we probably care about. So, I'm going to put that there. Okay, a Year 9 Mount Eliza secondary college student walks in front of him at a distance of 10 meters. So here's another bit of information. Now, most of this other stuff that's, most of the other words here aren't actually that important at all. If we can figure out what the important information is, then we can ignore the rest of the stuff. We've got two bits of information here. We've got a velocity. Now, I'm going to assume that's my initial velocity. I've got a distance or displacement value. Okay, shopping trolley's overloaded, blah, 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 blah. I can only decelerate the trolley at a rate of 2 meters per second. Can Mr. Benson avoid hitting the student? Okay, so there's a couple of things about this question that we need to think about when we're following this process. So you're actually given more information than you particularly need in this question. In that, sorry, I'm hitting wrong buttons here. Alright, you're given more information than we actually need in this question, because the distance up here of 10 meters, which I'm going to call X student, that's not actually relevant to whether I can stop the trolley or not, because if you think about all the other information that we're given, well, we're told that our it is our initial velocity, my bad, is 7 meters per second. Now, an implied value in this is, can I avoid hitting the student? Now, look, it's not a question about whether I can steer it, it's a question about whether I can stop it. So if I'm stopping it, what we're implying here is that I'm going to a final velocity of 0 meters per second. Now, other information, decelerate the trolley by 2 meters per second. So we've got A equals minus 2 meters per second squared. And the question's saying, can I avoid hitting the student? So what does that mean? It means that the displacement of the trolley when I'm stopping it has to be less than 10 meters. So what we're trying to find is the displacement. So now I've figured out all the information that I know and that I need to know, and so now I can go on to the next stage. So this is a key part of this. Think about all the stuff that you know and what you need to know. And then what you want to do is find one equation that suits that. So I've got U, V, A, and X. So working it out, I'm going to look in my list of equations. Now, these will always be on the formula sheet of any exam that you do. I wouldn't bother putting them on my cheat sheet for that reason. But what I find is that the one that's relevant here is v squared equals u squared plus 2ax. So it has all the terms in it that I'm interested in. Okay, then I'm going to substitute here. So final velocity 0, initial velocity 7, acceleration of minus 2, and x is what we're trying to find. In this case, you can see that I'm substituting before I solve. Okay, now the good, and as I've said, some of our terms disappear. So 0 squared is 0, equals 49, plus, now I'm just going to, in fact, I'm just going to make that minus 4x. Then I'm going to rearrange this to solve for x. So the 4x can go on that side, equals 49. X is going to be 49 over 4, which is some number, 12.25 meters. Now, the significant figures in this one, actually, they're pretty mangled because I haven't given enough information here. So it would probably be reasonable just to put that at 12 meters to two significant figures. Okay, so this is the way you should always approach these sorts of questions. So follow the steps. Be careful that you look through to find any information that's in the question. Think about any stuff that is implied. And also make sure that you are being careful to avoid any information that doesn't actually help you or that's not actually relevant to the question. So if we thought about this displacement value here and all the other values here, well, we actually would have had 4 numbers and they wouldn't have made sense in an equation anyway. It wouldn't have worked out properly. So sometimes you'll be given more information than you need for a particular equation, and you've just got to be a little bit thoughtful about that. So there are some examples on Compass that I'd like you to have a go at of this sort of thing, because it's a really important skill for Year 11 and Year 12.